all over our beautiful planet, beneath the surface of rivers, lakes, swamps, and creeks, live some of the most fascinating, overlooked, and understudied organisms, freshwater sponges. Now, many of you may have not heard of freshwater sponges, but today, you will learn how awesome these organisms are, how they shape our ecosystem, and how they've impacted the lives of more than 60 students at Baton Rouge Community College. First off, freshwater sponges have no true tissue, no symmetry, some don't even move. At first glance, they may look like a lump of algae or even a rock. But here's the surprise. They are alive, and they're quietly shaping the water around them. And here's what's extraordinary. Their entire lives are driven by the water they live in. Healthy water systems produce vibrant growing colonies, while polluted systems can leave them stunted or blackened. You see, freshwater sponges don't just survive their environment, they reveal the health of their environment. That's what drew me in as a scientist. In 2017, I received an email to participate in my first freshwater sponge survey in the New England states. And what I learned was, in the wonderful world of sponges, we find clues that help us understand and adapt to the changing health of our water system. To understand why sponges matter, we have to look at how they work. Freshwater sponges are covered with tiny openings that lead to thousands of canals. These canals are lined with specialized cells with hair-like flagella that beat and move water up and throughout the sponge. Every drop of water that moves through is filtered, removing bacteria, microscopic algae, even oils and heavy metals. And y'all, the impact builds up quickly. The sponge, a size of a fist, can filter an entire bathtub of water in a single day. But this filtration isn't the only part of its livelihood. Sponges can also form symbiotic relationships with other organisms. Freshwater sponges can host algae within their tissue, turning them bright green and gaining extra energy through photosynthesis. Marine sponges, on the other hand, may host bacteria that can produce antimicrobial compounds. Y'all, these compounds have already led to numerous new discoveries, such as antiviral drugs and cancer treatments. But for freshwater sponges, these properties are far less explored, but may hold similar but untapped potential. So it's not whether or not sponges matter, it's whether or not we're paying close enough attention. To understand how sponges live or how they're impacted by their environment, we have to look at their life cycle. Unlike other animals, freshwater sponges don't reproduce on a regular schedule. There's no spring mating season or annual cycle. Instead, they rely on a survival strategy more similar to plants than animals. They produce gemmules. Gemmules are tiny seed-like capsules that contain undifferentiated cells that can form new sponge colonies. These gemmules can reproduce sponges on many different pathways, but are mainly driven by the impact of their environment. These gemmules are extremely resilient. They can survive freezing waters, scorching summers, and drought to some extent. They can even survive digestion. A duck can eat a gemmule, fly to another lake, and deposit the beginnings of a new sponge colony. But resilience does have its limits. Warmer waters of climate change can cause these sponges to die back quicker, shortening their life cycle. Smaller or fewer sponge colonies means less natural filtration, so pollutants can build up in the environment, rippling throughout the entire ecosystem. Every aspect of the sponge, its growth, its survival, its reproduction, is a reflection of the water around it. Sponges are like mirrors, showing us a cumulative story of climate change in slow motion. And to me, that story became personal when I started studying them here in Louisiana. In 2019, I launched the Louisiana Freshwater Sponge Project. So the Louisiana Freshwater Sponge Project is a longitudinal study to monitor the freshwater sponge population. This longitudinal study monitors the freshwater sponge populations as they shift when the waterways change. With my team of undergraduate researchers, we monitor the sponge population continuously. Through these efforts, we have tracked and measured the water chemistry of over 400 water systems and analyzed over 2,000 sponge samples. And what we have discovered was that the species abundance in Louisiana has decreased since the last survey over 50 years ago. From the very beginning, I brought students into research with me. Some of them never imagining themselves as researchers, but there in the field, knee deep in rivers and lakes, and with sometimes snakes and alligator. They're no longer students, they are researchers. One of them told me after presenting at their very first scientific research conference, I never imagined research was for me. You see, for her, sponges weren't just model organisms to study. They became teachers. They taught her how to develop and test hypotheses. They taught her how to collect samples. They taught her how to analyze data. They taught her how to present at scientific conferences. But most importantly, they taught her and so many other of my students that they belong to the scientific community. You see, that is the beauty of this work. Freshwater sponges don't just tell us the health of the environment. They provide us with possibilities. Possibilities for science, possibilities for students, and possibilities for us to understand our place in this changing world. Freshwater sponges remind us that some of the biggest, most charismatic species don't always provide the biggest clues. Sometimes they come from the small, the quiet, the overlooked. Sponges are more than curiosities, living markers of environmental change. When they shift in color and shape and size or their life cycle shortens, they're telling us that pollutants are building, that biodiversity is changing, and climate pressures are mounting. Freshwater sponges are more than passive survivors. They are narrators of a story that we need to hear. And the story is this: resilience exists, but it is being threatened. If we want resilient communities, resilient ecosystems, resilient waterways, we have to pay attention to what the sponges are telling us. So the next time climate change feels too vast to grasp, remember this: sometimes the clearest signals come from the simplest animals.